Knowledge base contains information related to a particular domain. It has a static knowledge and dynamic knowledge. Static knowledge consists of rules and facts that does not change during the execution of the system. Whereas dynamic knowledge, it's related to facts that are collected by the system when the system is asking user about the various questions. So whatever user gives the responses, those will be recorded, and that encompasses a dynamic knowledge base. Inference engine. First of all, an inference refers to the process of searching through knowledge base and deriving new knowledge. And what does it involves? It involves reasoning and unification. We have learned this inference mechanism in logic concepts chapter, and also in semantic nets chapter. So what happens is you have if then rules, if this then that. Okay, so through that if then clauses, in inference is derived, uh, new knowledge is derived through inference. And you know that forward chaining and backward chaining mechanisms are also used for um, deriving new knowledge. Look at this example. If symptoms are headache, sneezing, running nose and sore throat, then patient has cold. If symptoms are this is second rule. If symptoms are fever, cough and running nose, then then patient has measles. So based on if then rules, it is decided, it is diagnosed, and it is identifying the condition of the patient. Okay, next one is these are all the components of expert system. We looked at knowledge base, inference engine, and now it is knowledge acquisition. Knowledge acquisition is about obtaining the knowledge. Typically, the knowledge is acquired by the knowledge engineer from the domain expert. Case history. Case history stores the files created by inference engine using the dynamic database. For instance, if a patient visit and consult an expert system, expert system asks various questions and patient gives responses, and all that will be recorded in one case file. And this case history um, is created from all the files that have been created over a period of time. Okay, so we in this case, when case is maintained, so case-based reasoning can be performed for particular cases. User interface is another component of expert system. User interface allows user to communicate with the system. Um, for instance, if you have to check for the mail, what is the user interface? You get a username and password field. So when you enter your username and password and say submit, then inbox will be um, shown to you. So that is a user interface wherein you are entering your password and username. Likewise, here for expert system also an interface is required through which user can interact with the expert system. Look at this dialog module of a user interface. System asks user, do you have fever? User say yes. System again asks, do you have sore throat? User says no. Going ahead, system asks, do you have cough? User says yes. Moving on, system asks, are you suffering from running nose? The user's response is yes. System asks, are you suffering from headache? User asks, says no. So this question answer series is you know done through user interface only. Explanation module. This facilitates uh, the expert system to provide some sort of explanation about the conclusion to which the system has reached. Through this interaction and dialogue between user and system has reached to a conclusion. And this why system has reached to this conclusion? Essentially, there may be certain reasons behind that. So that reasons telling why and how a part of arriving to a conclusion is performed by using explanation module. Look at this a series of dialogue. When system is asking, do you have running nose? And user say yes. Uh, the system is giving a kind of explanation here. I am trying to prove that you have cold. Do you have headache? Look at this here, this sentence. What is this sentence? I am trying to prove that you have cold is a kind of explanation given to the user. And then you do not have cold. This is also an explanation. Now I am looking at the possibility of measles. This is also an explanation. I can infer measles using the rule if symptoms are fever, cough, running nose, then patient has measles. So measles is concluded. This is the response along with the explanation given by the system to the user. When user asks how, system provides further explanation about the rule which um, which has been stored in that expert system. So that is about explanation module. There is another component, a special interface, which is used to perform specialized activities such as handling uncertainty in knowledge. For instance, what happens is uh, sometimes we may not be very certain about a particular knowledge. When we are not certain about a particular knowledge, we have to incorporate uncertainty factor while coming to a conclusion. That type of uh, scenario is handled using special interface uh, which uh, which incorporates a measure of uncertain and incomplete knowledge to derive new knowledge. And this process is known as reasoning with uncertainty. Next, in tomorrow's class, I hope that we will be starting probability theory, in which we will study how we can reason about uh, in um, cases where where we find an element of uncertainty. Next, okay, that those were the components of expert system. Next topic is expert systems versus traditional systems. What are the basic difference between them? Uh, if you recall, an expert system has been designed to perform a task that can be done by a human expert. So, a human expert is um, possessing knowledge, and based on the knowledge, a human expert derive new conclusions. We are trying to emulate this kind of behavior, uh, in machines. So, an expert system deals with knowledge, whereas a traditional system handles data. Uh, there is a difference between data and knowledge. Data is uh, some kind of facts and figures, whereas knowledge is applying um, mm, applying certain rules on that those facts and figures and coming to a conclusion. For instance, I may know everything about uh, heart. Heart has this functionality. It has arteries, veins, and all the parts of hearts and their functionalities, and so much of details about the heart I might know. However, I may not be able to diagnose a disease when a person or a patient arrives to me and states his or her uh, symptoms. Although I have the entire information about the heart, but I may not be able to uh, diagnose a condition. Whereas a cardiologist knows about the heart, everything about the heart, and also can apply that facts, figures, and rules to come to a conclusion about a particular disease or a condition of a patient when patient states his symptoms to the cardiologist. So knowledge and data are two different elements. Now data uh, is handled by traditional systems, which are database systems, whereas uh, knowledge is dealt in by expert systems. So this is the difference between knowledge system and uh, uh, expert system and traditional system. What are the key characteristics of expert system? Essentially, an expert system exhibit expertise. Expertise means an expert performance in the sense that For instance, if you go to a software organization where there are some senior programmers, very senior programmers, and there are freshers. Senior programmers uh, are having more knowledge, more expertise in solving certain kinds of problems, whereas fresh programmers may not be able to do it with expertise. So, over a period of time, the skills that are acquired and that knowledge that has been gained gives a person the expertise. So, similar kind of expertise an expert system exhibits. And symbolic reasoning, obviously, our expert system must be able to reason in the sense it must be able to derive conclusions. And self knowledge is like the explanation. System must be able to uh, explain the reasons, the justification for um, for deriving a new conclusion for its reasoning. So that is self knowledge. Learning capability, an expert system must be able to learn from its mistake and um, it should become more mature as it grows. Although expert system doesn't grow physically, uh, however it grows um, through experience. When it deals with a number of cases, then it gains more experience and it grows. And also it must show some kind of flexibility, and it must uh, it must be able to grow incrementally. Incrementally growing means learning part by part, learning things today and then learning some things new tomorrow. So incremental learning, ability to provide training. uh, when an expert system reasons about a particular case or a scenario, what it has to do is it has to provide training by explaining the reasoning process. Hmm? Uh, when it has solved a particular problem using its knowledge, it must be able to explain it to others. Means it must be able to provide training to another person or another system. And predictive modeling power, um, it is about explaining how new situation lead to the change, which helps users to evaluate the effects of new facts and understand their relationship to the solution. It is it is like the system must be able to possess some kind of predictive power in the sense that it must be able to say, because of this will happen in future, this may happen or this will happen. So that is predictive power. And then next is evaluation of uh, expert system. How can you evaluate an expert system? So uh, essentially you need to ask various questions to do this tasks. Does the system make decisions that experts generally agree to? A human expert, if human expert is agreeing to a particular decision, is the same decision taken by the system? Are the inference rules correct and complete? Um, a inference engine in an expert system consists of rules. So are they complete and correct? Does the control strategy allows the system to consider items in the natural order that the expert prefer? Um, it must do the things in an order which is preferable by the human expert. For instance, if a person goes to a doctor, doctor first asks all the symptoms, and then next step might be to ask the patient to get some tests done, and then doctor may prescribe medicines. This is the natural order. Is expert system able to do this order, or expert system is asking patient without asking listening any symptoms? If an expert system instruct a patient to carry out some tasks, some tests, diagnostic tests, without knowing why the patient has come, or after knowing and prescribing the medicine, and then asking patient to get the test done and not even checking the results, so that whether it is natural order or not. Are relevant questions asked to the user in proper order? um, question whether the questions are being asked in a proper order. As we saw the dialogue, uh, step by step, one by one, questions were posed by the system to the user. If they are um, um, you know um, proper and correct and in proper order, then user will not get irritated. Otherwise user gets irritated. Are the explanation given by the expert system adequate for describing how and why conclusions? Whether expert system is giving the conclusion explanation which is more relevant and understandable and suitable. If not, uh, expert system is not doing its job properly. Utility evaluation consists of answering the following questions. Um, does the system help user in some significant way? Whether it is useful or not. Whether an expert system is useful or not. That is decided by asking these four questions. Mm, if the system is able to help the user in a significant way. If not, it is of no use. Are the conclusions of the system organized and ordered in a meaningful way? If the conclusions are not organized and ordered, then it is meaningless. Is the system fast enough to satisfy the user? Uh, so, whether the system is taking a very long time, there should be um, acceptable time duration for any interaction. If the system is taking too long to respond or to pose a query, then it is again a useless. Is the user interface friendly enough? The interface with which user is interacting, is it friendly or not? Advantages and disadvantages. Mm, specialized knowledge problems. So, if an expert system is uh, solving problems pertaining to the domain, as human experts are scarce and unavailable, then the expert system will have lot of value. High payoff. Um, when the expert system performs the task in a proper manner, then we'll get a very high payoff. And existence of cooperative experts, uh, experts must be able to provide their expertise to you know to create a useful and appropriate expert system. So yeah, they should exist in um, both should exist together, and both should provide each other the required skills and knowledge. Justification of cost involved in developing expert system. If an expert system is developed with a reasonable cost, then it is fine. Otherwise, if it requires a very high amount, then it may not be that much cost efficient and effective and beneficial. A type of problem. So, if a AS system is developed to solve a particular problem, uh, which is hard to capture and represent, mm, and where and that problem can be solved only by human experts. So if an expert system is solving that kind of problem, then it gives more uses. Okay, next one, advantages. It helps in preserving scarce expertise. Suppose you exist in an area where there are very few cardiologists. In that area, few expert systems can be deployed, and then because the resource is scarce, um, many doctors are not available. So you can um, make use of expert system, provide consistent answers for repetitive decisions, processes, and tasks. So this is like it provides consistent answers. Uh, if if same kind of questions, same kind of answers has to be actually are involved in particular field, then it's better to use an expert system, because a human expert giving the same kind of answers again and again for same kind of questions will not make sense. So the pace fastens the pace of human professional or semi-professional work. Mm, it human professional work can the pace of human professional work or semi-professional work can be you can make it quick. You can fastly do the task by if you use a expert system. Next, it holds and maintains significant levels of information. This is um, clear. It holds, obviously, it holds um, a tremendous amount of information, and it provides improved quality of decision making. As the expert system learns, it becomes more and more aware about the different type of cases, and can improve its quality and can give good results. Domain experts are not always able to explain their logic and reasoning, unlike Most of the time domain experts may not have time also to explain why are they taking that decision. So, but however, expert system can give the explanation quickly and easily. Encourages organization to clarify the logic of their decision making. Um, this one is like when a organization uses the services of expert system, then they will be able to clarify the logic why they are taking that decision, because expert system can explain, because it has got explanation module. Leads to major internal cost saving within companies. Human experts have to be paid every month, whereas an expert system is developed, and it incurs one time cost, a huge one time cost. And then from its operational time, it may require some maintenance, but it does not need a monthly salary. So you can cut down so much of cost. And causes introduction of new products. You can introduce new expert systems, new products. And it never forgets to ask a question, unlike a human. Sometimes human tend to forget to ask certain questions which machine never forgets. It asks all the questions. And disadvantages, it is unable to make creative responses as human experts would in unusual circumstances. For usual and normal cases, expert system is great. However, in unusual circumstances, for instance, if a patient with a unique disease uh, consults an expert system, uh, then what happens is, because expert system has not been programmed in that manner. I'll get back. Okay, students, I'm back. So we are discussing disadvantages. What happens is, suppose a patient comes with a unique kind of disease, unique kind of symptoms which an expert system has not been programmed then expert system will not be able to ask proper questions and gives the right solution. And of course, obviously it lacks common sense. It is a machine, so that machine has been programmed with some rules, facts, and inference, mechanisms. So it does not have any kind of common sense. What it does is whatever has been programmed, same thing it uses for decision making. Sometimes it may cause errors in the knowledge base, which may lead to wrong decisions. What happens is, if knowledge base contains errors, obviously decisions will be wrong, because the decision making ability of expert system entirely relies on its knowledge base. If knowledge base is not right, then all the decisions what that it make are not the correct, and cannot adapt to changing environments unless knowledge base is changed. Uh, for we live in a world where the situation does not remain static. Things are very dynamic, but a machine does not know that. Unless a machine has been given the capability to learn, if it learns from its experiences, like we have a dynamic element, dynamic database, knowledge base, not, unless we incorporate dynamism in the system, it does not change its decisions based on the real world problems. So you have to change knowledge base based on the dynamic nature of the problems and situation. Languages for ES development, expert systems. Nowadays, all the nowadays expert systems do not actually exist, because the concept of developing expert system using if else clauses um, have become outdated, because now the entire AI is about machine learning and deep learning, in which we don't specify these rules. Machine has to learn the rules. So this is about a decade or 2 decades ago. When I was a student 2 decades ago, at that time, expert systems were uh, prevalent, and they used to be developed and they used to be deployed. But now everything is about machine learning and Python. So there was a language Lisp which I studied during my masters, and there was a language called Prolog which I studied during my masters, almost 2 decades ago. So these languages were used for the construction of this expert system. But nowadays, as I told you, there's no expert system. Everything is, machine learning and deep learning. Okay, students, I'll stop the class now. Um, in tomorrow's class, we will study about truth maintenance system, the next topic. Okay, I hope that today's class is understood by all. Have a good day. Bye. Take care.